When people think about the RMS Titanic, they often focus on its grand size, luxurious interiors, or powerful engines. Please, subscribe. But hidden beneath everything passengers could see was one of the ship's most important structural features, the double bottom. This engineering design formed part of Titanic's foundation and reflected the advanced shipbuilding ideas of the early 20th century. The double bottom was exactly what its name suggests, a second layer built beneath the main bottom of the ship's hull. Instead of having only one outer layer separating the vessel from the ocean, Titanic included an additional inner bottom above the outer hull plating. Between these two layers was a space divided into compartments and structural sections. This design served several purposes. One of the most important was protection. If the outer bottom of the ship were damaged by grounding or contact with underwater objects, the inner bottom could help prevent water from immediately entering the ship's main interior spaces. In other words, the double bottom acted as an additional barrier between the ocean and the ship itself. From an engineering perspective, the double bottom also strengthened the structure of Titanic. A ship of that size experienced enormous forces while traveling through the ocean. Waves, weight distribution, engine vibration, and cargo loads all placed stress on the hull. By adding another structural layer, engineers increased the rigidity and overall strength of the vessel. The construction of the double bottom involved a network of steel beams, plates, and supports connected throughout the lower section of the ship. These components formed a framework capable of distributing forces more evenly across the hull. Rather than relying on a single layer of steel, Titanic used a reinforced system designed to handle the pressures of ocean travel. Another important function of the double bottom was operational flexibility. Some of the spaces within the structure could be used for storage or technical purposes. Tanks for water and other ship systems could be integrated into the lower structure, making efficient use of space within the vessel. The design also contributed to balance and stability. Large ships require careful weight management to remain stable in the water. The lower sections of Titanic helped distribute weight and maintain the ship's center of gravity, improving overall performance during the voyage. However, the double bottom was not a complete double hull in the modern sense. While it provided additional protection beneath the ship, the sides of Titanic did not have the same fully enclosed double-layer structure seen in many modern vessels. This distinction is important because it shows both the strengths and limitations of early 20th century ship design. At the time Titanic was built, the double bottom was considered an advanced safety feature. Shipbuilders understood that grounding accidents could occur, and the additional layer provided a degree of security against certain types of damage. It reflected the growing emphasis on structural safety in maritime engineering. The double bottom also connected directly to Titanic's watertight compartment system. Together, these features formed part of the ship's broader safety strategy. Engineers combined multiple structural ideas in an attempt to improve protection and reliability during long ocean crossings. Looking back, the double bottom of the RMS Titanic reveals how ambitious the ship's design truly was. Titanic was not only built for luxury and scale, it was also designed with structural innovation intended to meet the challenges of the open Atlantic. It also reminds us how engineering evolves over time. Designers worked with the knowledge and technology available to them, applying the best ideas of the era to create stronger and safer ships. Many modern shipbuilding concepts continue to build upon these same principles. More than a century later, Titanic's structural design remains an important part of maritime history. The double bottom stands as an example of how engineers attempted to combine strength, efficiency, and protection within one massive vessel. In the end, the double bottom design of the RMS Titanic was more than hidden steel beneath the ship. It was a structural safeguard, a foundation built for strength and stability, a layer of protection beneath one of history's most famous vessels. And deep below the waterline, unseen by those above, that hidden structure supported Titanic's journey through engineering, ambition, and the shipbuilding vision of its era. It was a structural safeguard, a foundation built for strength and stability, a layer of protection beneath one of history's most famous vessels, and deep below the waterline, unseen by those above. That hidden structure supported Titanic's journey through engineering, ambition, and the shipbuilding vision of its era.